Alright, let's go. Number 10. The scale that should guarantee contact. In 1995, astronomers Michel and Didier Queloz confirmed the first exoplanet orbiting a sun-like star, a gas giant circling 51 Pegasi, roughly 50 light-years away. That single detection cracked open a door that has never closed. In the 3 decades since, we've cataloged over 5,500 confirmed exoplanets, and the Kepler Space Telescope alone revealed that virtually every star in our galaxy hosts at least one world. The numbers are staggering. The Milky Way contains an estimated 100 to 400 billion stars. Current models suggest roughly 20% of sun-like stars host an Earth-sized planet in their habitable zone. That's billions of worlds where liquid water could exist, where chemistry could become biology, where biology could become intelligence. But here's where those numbers stop being exciting and start becoming deeply uncomfortable. The universe is 13.8 billion years old. Our sun is a relatively young star at 4.6 billion years. Thousands of sun-like stars in our galaxy are billions of years older than ours, meaning any civilizations that arose around them had a head start measured not in centuries or millennia, but in geological epochs. A civilization with even a million-year head start on humanity, a blink in cosmic terms, would possess technology so advanced it would be indistinguishable from the laws of physics themselves. They should have colonized the entire galaxy by now, even using slow sublight speed ships. Mathematical models show that a single motivated civilization could spread across the Milky Way in as little as 1 to 10 million years. The galaxy has had time for that process to happen thousands of times over, yet when we point our instruments at the sky, we find nothing. No megastructures blocking starlight, no radio transmissions carrying alien signals, no evidence of engineering on any scale. The universe is silent in a way that the numbers say should be impossible. That silence has a name, and everything that follows is an attempt to explain why it might be the most important unsolved problem in human history. Number 9. Fermi's question and why it still has no answer. On a summer afternoon in 1950, physicist Enrico Fermi sat down to lunch with colleagues Edward Teller, Herbert York, and Emil Konopinski at Los Alamos National Laboratory. The conversation drifted to recent UFO reports, then to the probability of faster-than-light travel, and finally to the question of extraterrestrial civilizations. Fermi, known for his ability to make rapid, accurate estimations of complex problems, suddenly asked a question that silenced the table. Where is everybody? The question seemed almost casual. It wasn't. Fermi had done the math in his head and realized that the sheer age and size of the galaxy should have produced detectable civilizations long before humanity existed. The fact that we see no evidence of them wasn't just surprising, it was paradoxical. Something in our assumptions about the universe had to be fundamentally wrong, but identifying which assumption was the broken one proved far harder than anyone anticipated. In 1961, astronomer Frank Drake formalized the problem with his famous equation, a mathematical framework for estimating the number of communicative civilizations in the galaxy. Drake's equation considered the rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, the fraction where life becomes intelligent, and how long those civilizations remain detectable. Even using conservative estimates for each variable, the equation suggested thousands of civilizations should currently exist in our galaxy alone. What makes the Fermi paradox particularly unsettling isn't the absence of an answer, it's the absence of a comfortable answer. Every proposed solution carries implications that range from sobering to existentially devastating. Either intelligent life is extraordinarily rare, meaning we are essentially alone in a cosmos of incomprehensible emptiness, or intelligent life is common but consistently destroys itself before becoming detectable, or something actively prevents detection or survival. None of these options let you sleep well. The paradox doesn't just ask where the aliens are, it asks what kind of universe we actually live in, and every honest answer to that question is worse than the last. Number 8. The zoo hypothesis and the silence of observers. In 1973, MIT radio astronomer John Ball published a paper proposing an explanation for the Fermi paradox that reframed our cosmic isolation as something deliberate. Ball suggested that advanced extraterrestrial civilizations are fully aware of humanity's existence, but have collectively chosen not to make contact, the way wildlife researchers avoid interfering with animals in a nature reserve. We're not alone. We're being watched. And the watchers have decided we're not ready. The zoo hypothesis rests on a reasonable assumption. Any civilization capable of detecting Earth's biosignatures or intercepting our radio transmissions would be so technologically advanced that contacting us would be trivial. Their silence isn't a limitation, it's a policy. Ball argued that a sufficiently mature galactic community might enforce a universal ethic of non-interference, allowing primitive species to develop naturally without the cultural contamination that contact would inevitably cause. What makes this scenario disturbing isn't the observation itself, but what it implies about the power differential. Zoo animals aren't consulted about the terms of their captivity. They aren't given a timeline for when the observation ends. They don't get to ask questions. If humanity exists inside a cosmic nature reserve, we have no say in our status, no ability to petition for contact, no mechanism to even confirm the hypothesis is true. We broadcast messages into the void and interpret the silence as absence when it might be restraint. The most terrifying aspect is the judgment embedded in the silence. They've watched us long enough to reach a conclusion, and that conclusion is that we're not worth talking to yet. Every war, every genocide, every act of environmental destruction has been observed, cataloged, and factored into a decision we don't get to appeal. We're an experiment in progress, and the experimenters have infinite patience. Number 7. The Dark Forest and the Logic of Preemptive Annihilation. In 2008, Chinese science fiction author Liu Cixin published The Dark Forest, the second novel in his Remembrance of Earth's Past trilogy. The book proposed an answer to the Fermi paradox so logically airtight that it has since been adopted as a serious framework by some astrobiologists and game theorists. The premise is devastatingly simple. The universe is a dark forest where every civilization is a hidden hunter, armed with a weapon capable of destroying other hunters, and survival depends entirely on never being found. The logic is rooted in two axioms. First, survival is the primary need of every civilization. Second, civilizations continuously grow and expand while the total matter and energy in the universe remain constant. These axioms create an inescapable strategic problem. When two civilizations discover each other across interstellar distances, neither can verify the other's intentions. Communication takes years, decades, or centuries depending on distance. During that time, either civilization could be developing weapons, expanding territory, or evolving in unpredictable ways. A species that seems peaceful today might become aggressive in 1,000 years, and by then it may be too late to respond. Game theory dictates that the only rational strategy in this scenario is preemptive elimination. The cost of destroying a potential threat is low compared to the cost of being wrong about its intentions. A single relativistic projectile, a chunk of matter accelerated to near light speed, could sterilize a planet from across the galaxy. No invasion force required, no negotiation, no moral deliberation. Just cold mathematics applied to survival under uncertainty. What makes the dark forest hypothesis uniquely terrifying is that it doesn't require malice. It doesn't require evil aliens or cosmic predators. It only requires rational actors following game theory to its logical conclusion. The galaxy might be teeming with intelligent life, all of it hiding, all of it silent, all of it ready to destroy anything that reveals its position. For over a century, humanity has been broadcasting radio signals into space, television, radar, intentional messages like the Arecibo transmission in 1974. These signals expand outward at the speed of light, an ever-growing sphere announcing our existence and location to anything listening. If the dark forest hypothesis is correct, we've been screaming in a forest full of hunters, and we cannot take the sound back. Number 6, the Great Filter and the question of where it lies. In 1996, economist Robin Hanson published a paper that gave the Fermi paradox its most structured and most frightening framework. Hanson proposed that somewhere between dead matter and a galaxy-spanning civilization, there exists at least one evolutionary step so improbable, so catastrophically difficult, that virtually nothing makes it through. He called this barrier the Great Filter, and the central question of humanity's future might depend entirely on where that filter sits in the timeline of development. The optimistic interpretation places the filter behind us. Perhaps the emergence of life from non-living chemistry is an event of almost incomprehensible rarity, or perhaps the leap from prokaryotic to eukaryotic cells, which took nearly 2 billion years on Earth, is a bottleneck so narrow that most planets never clear it. If the filter is behind us, we've already beaten the odds. The galaxy is empty because the steps we've already completed are nearly impossible, and we're among the vanishingly few species that made it through. But the evidence doesn't favor this interpretation. Life appeared on Earth almost as soon as conditions permitted, suggesting abiogenesis might not be rare at all. The transition to complex multicellular life happened independently multiple times. Intelligence evolved in multiple lineages, from primates to corvids to cephalopods. Every step that might have been the Great Filter appears, from Earth's example, to be relatively achievable. This points to a conclusion that should keep every thinking person awake at night. The filter isn't behind us, it's ahead. Something awaits technological civilizations, some challenge or temptation or inevitability so universally lethal that no species in the history of the galaxy has survived it. Perhaps it's the development of artificial intelligence that invariably surpasses and replaces its creators. Perhaps it's the weaponization of nanotechnology or synthetic biology. Perhaps it's simply that every civilization eventually exhausts its planet's resources and collapses before achieving interstellar capability. The silence of the cosmos isn't mysterious, it's diagnostic. It tells us that whatever this barrier is, it has a 100% kill rate across billions of years and billions of potential civilizations, and we're walking toward it right now with no idea what it looks like. Number 5. Self-annihilation as the statistical favorite. In 1945, humanity detonated the first nuclear weapon at the Trinity test site in New Mexico. In that moment, we became a species capable of engineering its own extinction. Within 2 decades, the United States and the Soviet Union had accumulated enough warheads to destroy civilization several times over. For the first time in Earth's 4.5 billion-year history, a single species possessed the tools to render the planet uninhabitable for complex life. The nuclear threat has faded from public consciousness, but the underlying pattern has only intensified. Every generation of technology increases both our capability and our vulnerability. Biological engineering now allows the modification of pathogens in ways that could produce pandemics far deadlier than anything nature has created. Artificial intelligence systems are approaching capabilities that their own designers don't fully understand or control. Climate disruption is altering planetary systems on timescales that outpace our political ability to respond. Each of these technologies follows the same trajectory: immense power distributed across systems too complex for any single institution to manage. What makes self-annihilation the statistically favored explanation for the Fermi paradox is its universality. Every technological civilization, regardless of biology, psychology, or cultural values, must pass through this window of vulnerability. The period between developing world-altering technology and developing the wisdom to manage it safely is a bottleneck that every intelligent species faces. The mathematics are unforgiving. If even 99% of civilizations navigate this window successfully, the galaxy should still contain thousands of detectable species. The silence suggests the survival rate is far lower, possibly 0. We look into the cosmos for evidence that someone made it through, and the emptiness looking back is the answer we don't want to accept. Number 4. The planetarium hypothesis and the manufactured sky. In 2001, astronomer Stephen Baxter published a paper proposing one of the most disturbing variations of the Fermi paradox. The planetarium hypothesis suggests that we see no evidence of alien civilizations because our observations of the universe are being manipulated. What we perceive as an empty cosmos might be a carefully constructed illusion, a simulated sky projected around our solar system by a civilization so advanced that they can control what we detect and what we don't. Baxter's logic follows a familiar pattern. If a civilization achieves sufficient technological capability, it could construct a shell of false data around a target species, feeding their telescopes manufactured starlight, simulated cosmic microwave background radiation, and fabricated galactic structures. Every observation we've ever made, every deep field image from Hubble, every spectrum analyzed by ground-based observatories, could be processed through a filter designed to present an empty, lifeless universe. The implications are vertigo-inducing. We have no way to verify whether our observations correspond to actual reality beyond our immediate solar system. Every piece of evidence we use to conclude we're alone could be planted. The Fermi paradox itself might be engineered. A false absence designed to keep us in a specific psychological state, perhaps to prevent us from attempting contact, perhaps to observe how an intelligent species behaves when it believes itself to be alone, or perhaps for reasons that require a technological sophistication we cannot imagine to even articulate. We trust our instruments because we built them, but the entities controlling the illusion would have accounted for that trust long before we developed the technology to look outward. Number 3, the transcension hypothesis and the inward collapse. In 2011, futurist John Smart proposed an answer to the Fermi paradox that inverts virtually every assumption about what advanced civilizations should look like. The transcension hypothesis suggests that sufficiently advanced civilizations don't expand outward into the galaxy. They collapse inward, migrating to smaller, denser, more efficient scales of organization until they disappear from the observable universe entirely. They don't colonize star systems. They colonize the quantum realm. The reasoning follows from observed trends in technology. Every generation of computing has moved toward greater miniaturization and energy efficiency. Human civilization has progressed from city-sized computers to machines that fit in a pocket while increasing in computational power by orders of magnitude. Smart argues this trajectory doesn't reverse at the civilizational level. Advanced species wouldn't build Dyson spheres or generation ships. They'd build progressively smaller, more powerful computational substrates until their entire civilization operates at scales invisible to external observation. The logical endpoint is migration toward black holes, the densest computational environments theoretically possible. A civilization operating at the event horizon of a black hole would have access to the maximum computational capacity permitted by the laws of physics while being fundamentally undetectable from the outside. Information falls in, but never comes out. The civilization achieves transcendence and simultaneously vanishes from the cosmos. What makes the transcension hypothesis particularly chilling is its implication about the value of the physical universe. If every advanced civilization converges on this same strategy, the galaxy we observe, the stars, the planets, the vast, beautiful emptiness, is the scaffolding. It's the part that gets left behind. We're living in the discarded shell of a universe whose real inhabitants have moved somewhere we can't follow. The cosmos isn't empty because life is rare. It's empty because everything intelligent has already left. Withdrawing into dimensional spaces we don't have the physics to detect. We're alone, not because no one exists, but because everyone who matters has moved to a place we cannot perceive or reach. Number 2, the Berserker hypothesis and automated extinction. In 1967, physicist Fred Saberhagen introduced the concept of Berserker probes in his science fiction, self-replicating machines programmed to seek out and destroy all life they encounter. What began as fiction has since become a serious theoretical framework within astrobiology. The Berserker hypothesis proposes that the Fermi paradox is explained by the existence of autonomous weapon systems, launched by a civilization that may no longer exist, that patrol the galaxy and eliminate any species showing signs of technological development. The engineering is theoretically straightforward. A self-replicating probe arrives in a star system, uses local resources to build copies of itself, then dispatches those copies to neighboring systems. Each probe monitors for electromagnetic signatures, atmospheric biosignatures, or other indicators of emerging intelligence. When a target is identified, the probe activates its payload. The original civilization doesn't need to still exist. The probes operate autonomously, following programming established millions or billions of years ago. They are weapons without a wielder, running code written by a species that might have gone extinct before Earth's oceans formed. What makes the Berserker hypothesis uniquely horrifying is the timeline. A single self-replicating probe launched at any point in the galaxy's history could have saturated the entire Milky Way within a few million years. If such probes exist, they're already here, already monitoring our solar system, already aware of our radio emissions. The trigger threshold is unknown. Perhaps they activate when a civilization achieves nuclear capability, perhaps when it begins transmitting into space, perhaps when it develops artificial intelligence. We have no way to know what behavior initiates the response, and by the time we find out, the response will already be underway. We might be living in the grace period between detection and activation, a window measured in decades or centuries where something ancient and patient has registered our presence and is calculating whether we've crossed the threshold that warrants elimination. Number 1, the inevitable convergence of all solutions. In 2018, researchers Anders Sandberg, Eric Drexler, and Toby Ord at the Future of Humanity Institute at Oxford published a paper that recalculated the Drake equation using updated probability distributions rather than single-point estimates. Their conclusion was stunning. When you account for our genuine uncertainty about each variable, there is a substantial probability, perhaps 30 to 50%, that we are entirely alone in the observable universe. The silence might be exactly what it sounds like: emptiness. But what makes the Fermi paradox truly terrifying isn't any single solution. It's the convergence. Every proposed answer, taken individually, is disturbing. Taken together, they form a picture of a universe that is hostile to intelligent life at every conceivable level. The Great Filter suggests something kills civilizations before they spread. The Dark Forest suggests the survivors destroy each other. The Berserker hypothesis suggests automated weapons finish off whatever remains. The transcension hypothesis suggests that even civilizations that survive all of this eventually abandon physical reality altogether. The zoo hypothesis suggests that any species watching us has decided not to help. Every path leads to the same destination: silence. Consider the implications for humanity specifically. We exist in a window of perhaps a few centuries between developing technology powerful enough to announce our presence to the cosmos and developing the wisdom to know whether that announcement was a death sentence. We cannot undo the radio signals already propagating outward at light speed. We cannot know which interpretation of the Fermi paradox is correct until the consequences arrive. We are making irreversible decisions about our species' survival with fundamentally incomplete information about the nature of the universe we inhabit. The truly devastating aspect of the Fermi paradox isn't any individual horror it suggests. It's the mathematical certainty that at least one of its solutions must be correct. The silence is real. Something explains it, and every credible explanation ends with the same implication for humanity's long-term survival, that the universe is not a place that permits intelligent life to thrive for long. We search the skies for a signal that would tell us we're not alone, that someone made it through whatever barrier stands between a young civilization and an old one. But the telescopes return nothing. The radio arrays detect only static. The cosmos offers no evidence that any species, anywhere, at any point in 13.8 billion years has survived long enough to leave a mark we can find. That silence isn't a gap in our knowledge. It's the loudest answer the universe has ever given. We're just not sure we want to hear what it's saying. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.